Hello everyone, a big hi to all my warriors out there. So tell me everyone, how are you all doing? And let me tell you, bachalo, welcome to another beautiful session here. Okay. Now, what's so special about this session? I think you already might have gone through the title, right? Also, the cover page, let's say, right? Today, we are going to start one of the amazing and a very great chapter, which is Kinetic Theory of Gases. Just like there is theory, it is a theoretical chapter, right? So we have to learn a lot much of theory. So I hope you all came with full of patience and to learn this chapter to its depth. So here you go, मेरे बच्चा लोग. This is Ameer, your physics educator at Unacademy. And before we start with the session, I would like to know how all are my बच्चा लोग doing. So everyone in the chat box, update me. कैसे चल रहा है? Okay, how's everything going? Shreya, good evening. Varsha, hi. Okay, you are new here. I'm so happy to have new students here. ठीक है? So Yashika, before you leave the class, tell me how the session was. ठीक है? Ashutosh, Pardeep, good evening Pardeep. Devika, Shivali, Payal, Sumit. ठीक है श्रेया, अमन, म्यारा, विपिन, साक्षी, अरे निता, पुरोहित, बहुत सारे लोग हैं आज, है ना? So I'm so happy to have so many new students here in this classroom. I welcome all the new students here and let's all begin the session with a beautiful smile on our faces. ठीक है? देख ले. If you are seeing me for the very first time, a bit of introduction about myself is given here. I have an experience of more than 3.5 years in the field of teaching as a BTech teacher, as an IT teacher, right, or JE in the field of NEET and in the board examination. I'm a BTech graduate from an IT Calicut in mechanical engineering, and that's all about me, let's say, for the time being. Moving on. Now I'll just show you the schedule for this particular week, and let's say, as you all know, we are almost at the end of the week. And on 28th of Jan, which is tomorrow, what we will be having is the Mega Mendi quiz, bachalo. We have completed many chapters from term 2, right? Just say solids, okay, mechanical properties of solids and fluids, thermal properties of matter, thermodynamics. So from all these 4 chapters, tomorrow we are going to be doing a very big Mega Mendi session. I really want to see who's going to be on top of tomorrow's Mendi session. Okay? Now, if you want to get all the updates of what happens in our YouTube channel, bachalo, this is your chance. You can be a part of the Telegram channel. The link is given here and also in the description box. Moving on, Bugs Bounty. क्या होता है Bugs Bounty? It's an amazing program which can help you to get lot much of prizes. What do you exactly have to do? You just have to go to the description. Okay? There you'll find a form. Fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारा प्राइसेस आ जाएगा बच्चा लोग आपका घर को. ठीक है? So don't miss your chance. Now, is there anyone who haven't written this Unacademy Combat scholarship test? Bachcha log, this is your chance. Why you have to wait so much of scholarships and so much of gift which is actually waiting for you? Shall I tell you what all you were missing till now and what you can get if you write the scholarship test? देख ले. Everybody look at me. If you get a first rank, it's gold medal waiting for you. Second, silver, and for the rank 3, bronze medal. And for the first 3 ranks, okay, the gifts are not yet completed. 1 year of Unacademy free subscription is given mera bachalo for the first 3 ranks. Others, you don't have to worry. For a rank of 150, scholarships are being given. Why you have to wait, right? Who's actually stopping you, bachalo? Come and join the classroom and be a part of this Combat scholarship test. And let me tell you, this is completely free. You don't have to pay anything. Right, you can just sit at your home, you can register for this completely for free, but just remember to use the code of AMB10 while you register for it. Okay? So the code is AMB10. You can register for the scholarship test completely for free. Moving on. Now, I want to tell you one thing. If you haven't shared the class to all your friends and asked all your friends to join the class as soon as possible, this is your turn. Okay? Share the class to all your friends and ask them also to come because we're going to start a new chapter, right? Let's learn together because the happiness will become more if there are more number of people in the class. What do you all say? Jia, Devega, Anshika, Myara, Tanmay, Pardeep, Mithilesh, everyone, right? So jaldi say, share the class to all your friends, ask them to join as soon as possible. In the meanwhile, if anyone is new here who doesn't know about Unacademy platform, right? What all amazing features you can enjoy once you're a part of it, I'll just tell you. Nowadays we are learning through YouTube, right? And like I say in all my classes, yes, it's awesome, it's super. But there are certain features and things which you miss in YouTube, such as personal guidance and mentoring directly from the educator, right? Let's say you want to clear your doubt whenever the educator is taking the classes, right? So this can happen once you're a part of an Academy subscription platform, because in the platform we have the live chat box and the question tabs where you can upload all your doubts and get it cleared. One thing, let's say still your doubt is not cleared, we have a feature called as in-class calling facility. Matlab, you can call your educator, talk to him and get your doubts cleared during the live class itself. What else you want, right? I haven't completed the top educators of the country who's having a very good experience is going to be there to teach you. With their high experience, they will be knowing what all examination pattern you should be expecting for the exam. One thing, what all exam questions you should be doing, okay? What all examination questions you should be preparing so that you can make the best preparation for term 2. Okay, what will be happening? Obviously, right? You will ace in all the examinations you write, and you will be ending up in the colleges whichever you are dreaming about, isn't it? Then study material, practice tests, live test series, everything will be there to make your studies to move a level up. So if you go for 12 months of plus subscription, it should cost you 1,250. But again, we need not to pay that much because we have our code of AMB10. Use this, get 10% of discount and be a happy member of an Academy family. Start learning with us and get your maximum score for all the examinations. Now, if you go for Iconic, you'll get all the features what I have described for plus subscription. Plus some extra features will also be there, such as personal mentor. Nowadays, you take a lot of time for planning, hai na? Matlab how much to study, what to study, aaj kya padhna hai. You'll be spending lot much of time. Once this person is there, he'll be looking after all your academic activities. So you can feel free for all those time and you can use that time for your studies. Matlab you'll feel so comfortable, you will feel so relaxed once this person is assigned to you. Live doubt solving classes, weekly reports. For enjoying all these things, you can go for Iconic. If you go for 12 months, it will cost you 2,333 per month. And as you all know, we have our code to save us all the time. So use this, get 10% of discount and maximum offers while you make the subscription. Let me tell you, this is the last day for availing for Republic Day special offer, right? If you go for 12-month subscription or more than that, you'll be given extra 6 months to you. So don't miss your chance. Okay? This offer ends today. So if you want to make a subscription, don't think much. This is your chance. So you can make it happen. And the code is AMB10 for extra 10% of discount. Let me tell you one more thing. Today we have a special class at 10 p.m. Fine. Its special classes happens on the app and it is completely free. From thermal properties of matter, we're going to solve some extra numerical questions. It happens at 10 p.m. today after this class. It's free. If you want to join, you can click on the link which is on top of that chat screen and you can be a part of this class. It's completely free. Okay? Click on the link and use my code of AMB10 to be a part of this class. Okay? One more link you can see if you want to follow my Unacademy profile where you can get the notifications of all the free classes. That can also happen. Now, I just want to ask you, how many you came, right, with that mindset, right? I'm going to learn this chapter of Kinetic Theory of Gases completely with Ameer Bhaiya and I'm going to start right now. How many of you came? Because others who just came for visiting, right, this is not going to do anything. If you came with that mindset of learning this topic, I can make that happen for you. You have to be with me, right? You have to listen to the complete theory and you'll start loving it. Sudeep, Shreya, yes, hi Sudeep. Aishida, Anisha, just tell me, how many of you came with that mindset? Sakshi, energetic. Bhumika, yes. Jia, we are ready. Devika, you came with that mindset. Very good. Sumit, Shreya, Hina, Pardeep, Maitri. So, sub, hai na? Sana, hi, Ami. Hello, hi, Sana. Okay. So, everyone, those who came for studies here, okay, take out your notebook, everyone. Take out your pen and write the heading. Kinetic Theory of Gases. Very good theoretical chapter. Shall I give you an introduction of what we are going to learn in this particular chapter? Dekh le. Now, everything started when John Dalton, right, the scientist with the name of John Dalton, made the discovery of what? Made the discovery of atoms. So, in the early days, in the early centuries, John Dalton found out that every material, whichever material you take, है ना, let it be water, let it be iron, let it be air, let it be any other gas, everything is made up of very small indivisible particles that is called as atoms. And he also told that the property of any material, property of any material is totally dependent upon the atoms. I think you might have already learned this from your chemistry classes. Okay, fine. This was the beginning. After this, after some years, okay, there came this kinetic theory of gases. Okay. And do you know what was said in kinetic theory of gases? John Dalton said all the properties are based upon atoms, and they made a small correction here, the kinetic theory of gases. They told that it's not the atoms, it is the movement of the atoms. Because when we compare all the states of matter, solids, liquids and gases, gases molecules move about a lot, right? Because they are very free to move because of very less force of attraction between the molecules, है ना? So they are very free to move. They ऐसे it will be moving around all the time. So kinetic theory of gases said that it is the movement of the molecules. The movement of the molecules which is responsible for all the properties of the matter. When we say movement, what is included in that? Yes, kinetic energy or speed. So once again, if we make a statement, we can say that kinetic theory of gases said that it is the kinetic energy or the speed of these moving atoms are responsible for all the properties of the gases. Properties, let's say, such as pressure, temperature, all are responsible or all can be explained by using this kinetic energy or speed. And we are going to make the derivation also here. What derivation? Derivations for pressure in terms of speed, derivations for temperature in terms of speed. What is the formula for kinetic energy in terms of other properties? Let's call it as pressure and volume. Okay? So many derivations are also going to be done. Everything is on the basis of the movement of the particle or the kinetic energy of the particles. And this is exactly what we are going to learn in this chapter. A choto introduction, right? In detail, we are going to learn about kinetic theory of gases. Postulates also we'll be learning in today's class. So be here itself. Okay. Now, you all came here after learning chemistry, right? Now, how many of you know what is the name given to the gases, right, which obeys all the gas laws? Okay, every law related to the gas, right, that is being obeyed, we call a certain name for that. What is the name? It is called as ideal gas. Now you will be thinking, right, sir, is there a set of gases, right, where we give a name as ideal gases to them? Is it a combination of oxygen, nitrogen, then helium? Do we call the combination as an ideal gas, right? Is it so? No. Ideal gases matlab they are the imaginary gases, right, which will be obeying all the gas laws, okay, which is existing, right, which will be obeying without making any deviation. Okay, such kind of gases we call it as ideal gases. You will be asking, are there such kind of gases? No. Like I told you, ideal gases are imaginary gases, just exist in our imagination, in our mind. Okay, and this imaginary gases, what will they do? They'll be obeying to all the gas laws. You might have learned all the gas laws before, such as Boyles Law, such as Charles' Law, right? You might have learned all these laws. So those gases which obeys all the gas laws and every laws related to the gases without making any deviation, such gases are called as ideal gas. I'll give you an example. Okay, now let's say for parents, right, a newborn baby is going to be there. Now before the kid is born into this world, the parents will be having their own imaginations, right? They'll be thinking that my son is going to be or my daughter is going to be so studious, right? He is going to be having a very good career as a doctor or an engineer. Okay, he'll be so active, he'll be doing that, he'll be doing so much of imagination will be there, right? Does that kid actually exist? No, that is the ideal kid or the imaginary kid that is in their mind. But when we come out, right, let's say me, you people, what happens? We'll be having so much of deviation. Let's say we'll be the most, in my case, let's say, okay, kid can be so mischievous, right? Some kids are who's not at all interested in studies because they'll be loving to do some music or something. Matlab, a lot of deviation happens from this ideal cases. Matlab, we have the real kids, okay, which is existing, and here we have the ideal kids. So ideal kids exist only in the imagination. Such a way, these ideal gases exist only in the imagination, which obeys all the laws. Okay, what we have is real gases. Okay, but this real gases or this real kids, right, will be acting like ideal kids, or real gases will be acting like ideal gases in certain conditions or situation. Jaise, sir, can you give an example? I'll give you an example. Real kids है ना, देख लो चलो. Real kids, okay, let's say the parents are offering a laptop if that kid get first rank. So we are giving some offering to that particular kid. So obviously he'll start studying. Somehow let's say that real kid got first rank. Matlab, the real kid is becoming almost like an ideal kid in certain situation. Situation is here in this case we are offering some gift. Similarly, in the case of gases also, this real gases sometimes will be acting as an ideal gases also. We are going to see in which all cases this real gases are going to act as ideal imaginary gases. Okay, so these are all the things that we will be dealing in this particular chapter. आ गया समझ सब लोगों को? इधर तक आ गया सब लोगों को? What we are going to learn in this chapter? क्या क्या cover करेगा हम? जल्दी बोल दे. Aryan, Mera, Shankamitra, Sudeep. Right? Sudeep was like, sir, that is impossible. I think you're talking about the first rank case, है ना? Sakshi, Mithilesh, right? Okay, yes. Okay, fine. Now, like I said, ideal gases are imaginary gases. You can also add this small point to ideal gas that it obeys all gas laws, okay, without any deviations. Fine. I hope you all have noted this down, and it is very important also. Okay. Now, कोई doubts नहीं है ना? चलो इधर तक. Shall we proceed? Okay. We are moving on. My question. Okay, or you all can have this question also. When the kinetic theory of gases came into the scientific world, or when it was applied for all the gases, why it got that much of support from all the people? Okay, why it was so much success, this kinetic theory of gases? Very simple. Kinetic theory of gases find its success, or people believed in this kinetic theory of gases very easily because kinetic theory of gases, right, was able to explain all the laws related to gas which was existing beforehand. Okay, now, so you'll be asking, sir, which all were the laws that was existing before kinetic theory of gases? You all will be knowing, right? Boyles Law, Charles Law, Avogadros Law. So obviously, before we start with kinetic theory of gases, which actually explains this Boyles, Charles and Avogadros Law, don't we have to go through this Boyles Law, Charles Law and Avogadros Law in detail? And obviously, we'll be learning one new thing. I know that once you hear the Boyles Law, Charles Law and Avogadros Law, you'll be thinking, sir, yes, humko pata hai, we have learned in chemistry. But we are going to learn some new things here, right, which you haven't learned in your chemistry classes, that when are these ideal gases, when are these real gases going to behave like ideal gases? This is going to be explained in detail while we deal with all the laws of gases. Okay? So everyone write down the heading as Boyles Law, because we are going to discuss about all the gas laws before we start with kinetic theory of gases. Everyone write the heading, everyone, very important. First heading, Boyles Law. Tell me what is said in Boyles Law. In Boyles Law, it is said that if we can keep the temperature as a constant, it was found out that the volume is inversely proportional to pressure. सबको पता है, right? There is no explanation needed for anyone in this class for this because you already know and we already have completed thermodynamic process, है ना? If you are keeping the temperature as a constant, Boyles law found out that the volume is inversely proportional to pressure. मतलब, if we are having a container of some volume V, let's say the pressure is P at that time. Now, if we increase the volume, it was found out that the pressure is decreasing. That is simply told in Boyles law. ठीक है? Let us draw a diagram. Diagram मतलब we are going to draw a PV graph, a pressure volume graph in order to express this Boyles law. How will it be? अरे V equal to 1 by P मतलब just like Y equal to 1 by X graph. What was the shape of Y equal to 1 by X graph? ऐसे hyperbola, है ना? So the graph will be like this. Let's say while we were drawing this, we kept the temperature as a constant and that constant temperature is T1 throughout. Okay, this was a graph obtained. But you have to know that this graph is for which gas? Is it for real gases? No, this is for ideal gases. Because it is the ideal gas which obeys all the laws without making any deviations. Okay. Which means if we draw the same PV graph for the real gases, how will it be? Scientists wanted to know, right? Okay, how much the real gases are behaving like ideal gases. So what they did? Simply, they took a container, okay, they took some gases inside, they kept the temperature as a constant for this gas throughout the process. Then they kept on changing the value of pressure and volume. They kept on changing and the graph was plotted according to the values observed or got from the above experiment. And how it was looking like? The graph was almost looking like this. Matlab, when the graph was plotted, shape of the graph was almost the same, but it is not coinciding. Matlab, in the real situation, a chotu deviation was observed, okay, when the PV graph was plotted. A chotu deviation. So this graph is for a real gas at a temperature T1. Okay. Same graph you can find in NCERT also. Okay, sir. Or explain kar liya. Now, do you know what I did? This entire experiment was conducted at a temperature of T1. Now, for this gas, I increase the temperature. Matlab, now you increase the temperature of the entire gas to a higher value, T2. Now, we again draw the PV graph for an ideal gas. We increase the temperature from T1 to T2. Now we are keeping the temperature as T2 as a constant. Now we are going to draw the PV graph for the same. How will it be? कैसे हो जाएगा? अरे temperature increase हो गया. You all know this formula, right? PV equal to nRT. If you try to draw the PV graph at a higher temperature, will it be at the bottom of the already existing or will it be on the top? Array on the top. Why? For higher temperature, value of P and V will be larger. For having larger value of pressure and volume, the graph should be where? Either. So, when the temperature of the entire gas was increased to some T2 value and the same PV graph was plotted, the graph was found to be here. Okay? And this was for ideal gas. Ideal gas. Now, when the same PV graph was plotted for a real gas, like we have already explained, the graph was like this. You take a new color. New color. The graph was like this. Acid, which means that at higher temperature, you can see that the graph is almost coinciding. What we can say? We can say that at higher temperature, T2 is a larger temperature, right? At higher temperature, you will see that the real gases are acting almost like an ideal gas. And this is the first observation that has to be carried from here or from the Boyles law. What is it? What is it? At higher temperature, you will see real gases behaving almost like an ideal gas. इसका मतलब ये कि, right? If you want a real gas to obey all the gas laws, you want to keep the temperature of that real gas higher. So it'll be obeying all the gas laws without making any deviations much. समझ में आ गया? Can I write it here? What can I write? We can say that real gas will behave like ideal at higher temperature. It's very important मेरा बच्चा लोग, ठीक है? It's very important. So I have just resize the screen so that you can see the entire text here. Jaldi se copy it down. Everyone copy down the entire concept, and let me tell you, this is super duper important it is. नोट किया सबने? जिया, लेट्स से सुमित, म्यारा, अंशिका, देविका, ओके, भूमिका, कोई भी डाउट है तो बता. और इफ एवरीथिंग इज क्लियर है ना, वी आर गुड टू गो. वी कैन डू सम प्रॉब्लम्स, राइट? आई थिंक यू ऑल डू लव प्रॉब्लम्स, है ना? छोटू छोटू नन्नू मुन्नू प्रॉब्लम भी कर सकता है. लूसीफर, श्रेया, गेमिंग, सोफिया, डन एंड डस्टेड. ओके, जल्दी जल्दी जल्दी. Waiting. Ishita, Suresh. No, not low temperature, at higher temperature. Okay, at higher temperature. ठीक है. Okay. Now I don't think anybody is having any doubts, and बच्चा लोग are like, sir, questions दे दो हमें. ठीक है, दे दूंगा मैं. बहुत सारे question दे दूंगा. Okay, ये तो आपको पता है ना? Before even me telling, volume is inversely proportional to pressure, or you can say that volume is equal to a constant by pressure, converting this proportionality into an equation. So PV is equal to a constant. So we can say P1 V1 value is equal to P2 V2 value. सबको पता है, I suppose. So that's why I'm not going to stress on this. You already have learned from your chemistry classes, and also in the thermodynamic process. This is the example for an isothermal process, है ना? We have learned, ठीक है? So let's start doing the problems. Okay, and here it comes. Nannu munnu problem है. And what does it say? देख ले. A gas is an environment that has a volume of 16.8 liter, fine, and a pressure of 3.2 atmosphere. Initial volumes are given. If you want, I can mark it as V1, and initial pressure is given as बच्चा लोग P1 है, ठीक है? If the volume changes to 10.6 liter, let's call it as V2, what will be the new pressure? अरे, my regular students know what do I call these kind of questions? हाँ, नन्नू मुन्नू questions, right? Everybody can do all these kind of problems. जल्दी कर ले. We can start the new law, नया law. Who's gonna give me the answer? Who is gonna give me the answer? Who's gonna give me the answer? Mithilesh, Jia, Sumit, Bhumika, Jia. ठीक है. Okay, everybody is going for the option C here. Yes, it's correct. It is 5.07 atmosphere. Right? Without any guesses and without any confusions, you all know how to do this. Initial volume given, pressure given. ठीक है? Final volume given. What is the final pressure? कैसे? P1 V1 equal to P2 V2 बच्चा लोग, है ना? P1 कितना है? 3.2. V1 कितना है? 16.8. What is P2? अरे पता नहीं तो पता करो. V2 how much? 10.6 हो गया. So P2 is equal to 3.2 into 16.8, the whole divided by 10.6. ठीक है, 16.8 by 10, almost let's say 1.6 into 3.2 is a value greater than 5, let's say. So it has to be 5.07 atmosphere. So P2 is 5.07 atmosphere. Because we have considered initial pressure in the units of atmosphere. Okay, that's why we got the final answer in the unit of atmosphere itself. Happy, super happy. Okay, now proceed further, है ना? Noted? 5 seconds. 5, 4, 3, 2, 1. Done. चलिए मेरे बच्चा लोग, हमारा अगला लॉ Charles law. Okay, so here also we will see when ideal gases are behaving almost like, when real gases are almost gonna behave like an ideal gas. We'll see that. ठीक है. What is said in Charles law? कौन है? किसका लॉ है? Charles law, sir. ठीक है. Now, in Charles law, it says that if we keep the pressure as a constant, we are not changing the value of pressure throughout the process, right? It was found out that the volume is directly proportional to temperature. But this law is very important and prone to so much of mistakes, though it's very simple. ये temperature है ना, it's very much important that we have to take in Kelvin scale. If you take in degrees Celsius, Fahrenheit or any other scale, this will not work. ठीक है, you'll get the wrong answer. That's what you mean that it will not work. ठीक है. So volume directly proportional to temperature. मतलब if you take a volume of a container with some gas at some initial temperature T, if you think of increasing the volume of the container, temperature will be increasing. Or if you increase the temperature of the container, volume will increase if pressure is kept as a constant. And this is simply Charles law. Okay, we can draw a graph also for the same. Graph कैसे हो जाएगा? अरे, let's say that I'm plotting volume here and temperature here. How will the graph be? Volume directly proportional to temperature. So it will be a straight line, I say. Zoom. है ना? ऐसे zoom वाला straight line हो जाएगा. ठीक है? Now, this is the graph for an ideal gas. है ना? The gas laws are obeyed all the time by an ideal gas only. Now, let's say I'm taking a separate gas in a container. I keep the pressure as a constant. Now I change the volume and note down the corresponding temperature. I made it to a graph. Okay, I collected all the points and I am making into a graph. How will it be? कैसे हो जाएगा? अरे, the graph will be like this, like this, like this. क्यों? Okay, the graph of a real gas will be like this. How many of you can understand what I have did there? क्या किया मैं देख ले. At lower temperature, the real gases and ideal gases were not at all matching each other. There was a huge deviation between them. मतलब real gases were not behaving like an ideal gas in simple words. But देख ले, as the temperature increase, we can see both the graph will be coinciding, or let's say at higher temperature, like we already have discussed, right? Real gases will be behaving almost like an ideal gases here. Okay, real gases will be acting almost like an ideal gas here, like we already have explained. So I'm not writing the statement here because we have written the statement beforehand. What's the statement? Real gases will act like ideal gases at higher temperature. ठीक है? Fine. Okay. Moving on. एक और बात I have to add to this is that मेरा बच्चा लोग, this one, converting this volume proportional to temperature. How will you convert proportionality into an equation? By multiplying it with a constant, which says V by T equal to a constant. You will be like, sir, ये हमको पता है. Anyway, मेरा duty है. I'll do it. ठीक है? So those who want to note it down can note down this also. V by T, if it is constant, what can we write? We can write V1 by T1 will be equal to V2 by T. Fine? Is it clear? बहुत अच्छे से clear है? अच्छे से clear? Okay. Now, we have learned Boyles law. है ना बच्चा लोग? What do you all say? Note भी किया अंशिका? Jyoti? Lucifer? HBRB. Avishiga, Broken, Anera, Meru, Smart Boy, M24 Gaming. Everyone done? Okay, एकदम clear, super clear. V1 by T1 is equal to V2 by T2. ठीक है? Okay. Now, shall we combine these two laws? How many of you are interested? For the combination, है ना? ऐसे जुड़ने में किसको मजा आता है? किसको मजा आता है? Noted in mind है ना? मुझे पता है. Audible cleared. Okay. ठीक है, ठीक है, ठीक है. Let's see. Okay, let's see how we can combine the Charles law and Boyles law. Then we will start the problem. ठीक है? How are we going to combine? According to Boyles law, it was found out that volume inversely proportional to pressure. ठीक है? Obviously at constant temperature. At constant temperature. Now, at constant pressure, we have Charles law which says volume is directly proportional to temperature. Try to read both of this. Volume inversely proportional to pressure, volume directly proportional to temperature. If you combine this and write, we can have volume directly proportional to temperature and inversely proportional to pressure. Thus, by combining Charles law and Boyles law, by combining Boyles and Charles law, we have this equation over here. ठीक है? We can convert this actually into a equation also. कैसे? अरे ये सबको पता है. अरे proportionality conversion. I think everybody loves this, right? By multiplying it with some random constant. Rearrange. P comes to the numerator. V by T. T will come as the denominator. Is a constant. So how can we write this? From here we can obtain that P1 V1 by T1 is equal to P2 V2 by T2. ये भी note कर ले सबने. This is also important because we are going to solve some questions. Okay, एक अच्छा question आ रहा है from NCERT. So ये भी जल्दी से नोट कर ले बच्चा लोग. We are going to solve some question. अच्छा बढ़िया questions करने जा रहे हैं हम, which requires this concept and you will also love it. नोट किया ना सबने? Okay. Noted. There we go. Payal, Sumit. Clear? Okay. So ready for the questions, everyone? Let me see who's the first person, right? Who's gonna give me the answer this time? Okay. कौन हो जाएगा पहला? Number 1. तू मेरा तू मेरा तू मेरा तू मेरा. बच्चा लोग कौन है? Who is number 1? तू मेरा तू मेरा तू मेरा तू मेरा तू मेरा. कौन है number 1? कौन हो जाएगा? जल्दी कर ले and prove who is gonna be the number 1 here in this class. Everyone, जल्दी से फटाफट. Who is that number 1? तू मेरा तू मेरा तू मेरा तू मेरा. कौन है तू मेरा? Sumit, I am not able to find the right answer. Okay, that's why I'm not calling out the names here. Correct. I only want the correct answer. Everyone is going for the option A here. Option A here. क्यों? अरे everyone option A को जा रहा है. ठीक है. देख ले कैसे करेगा. Okay. A gas occupies a volume of 400 centimeter cube. मतलब initial volume is 400 centimeter cube, right? Okay. Now temperature is 0 degree Celsius, so should be substituting it as 0. मिलना चाहिए क्या? अरे it has to be in Kelvin scale. 0 degree Celsius सबको पता है, right? The freezing point of water it's 273 Kelvin. So initial temperature भी मिल गया. and 780 millimeter of mercury. So it says the pressure is equal to 780 millimeter of mercury. Okay. How many liters of volume will the gas occupy at 80 डिग्री सेल्सियस? अरे बच्चा लोग कन्वर्ट करने को भूलना मत. 80 डिग्री कितना होता है? 273 प्लस 83, ओके 14 15 353 हो जाएगा सर. ठीक है. So temperature T2 is 353. Now how can we do this? Don't think that we have to add the pressure here. देख ले, pressure is remaining as a constant always 780 millimeter of mercury. So simply application of Charles law, get the answer and happy ho ja. Okay. What is the formula? V1 by T1 is equal to V2 by T2, right? So V2 is equal to how much? V2 equal to T2 divided by T1 into V1. ठीक है. T2 कितना? 350. T1 कितना? 273. So this is 353 by 273 into how much is V1? This is equal to 400 centimeter cube. Okay, so here we will get this as 517 centimeter cube as final volume. But answer is in liters. How will you convert centimeter cube to liters? Multiplying it with what? कैसे? 10 power minus 3. So we'll get the answer in liters. So this is equal to 0.517 liter. ये आ जाएगा हमारा अंतिम और फाइनल. अंतिम और कौन? फाइनल आंसर. अंतिम और फाइनल आंसर मिल गया. ठीक है. सी है. I think you already might be knowing, and seems like either you might have forgot to make the conversions of temperature or multiplying it with 10 power minus 3. I don't know why everyone was going for option A there, but it was pretty obvious, right? Option was C. Okay. एक और. How many of you want to do एक और question? So your answer is our answer. Hey, don't believe me उतना तो. Okay, मैं उतना अच्छा लड़का नहीं है. Okay, sometimes I also make some ऐसे वाला things. ठीक है? Some mischievous I can be. So don't trust me all the time. तो ना अर्शदा, म्यारा, श्रेया, राशि सब बढ़िया ना? Okay, थोड़ा time. You need some time to solve the problems. Fine, I'll give it to you. है ना? Whatever you ask me, I'm gonna give you. ऐसा वाला अच्छा भैया हूँ मैं. Okay, you will even feel like है ना, your actual brother is also just like me. ऐसा हो जाएगा मैं. साक्षी, सोफिया, मानसी, ठीक है. नेक्स्ट क्वेश्चन चाहिए ना? सर बकवास मत कर ले सर, अगला क्वेश्चन दे दे. बहुत सारे करना है सर. Okay, next question is here, and nobody reminded me to wear the chashma. क्यों नहीं करते आप लोग? Now there you go. Read the question properly. अच्छे से. Okay, and give me the answer just like that. There you all go. $30 seconds. Will that be fine? Will that be fine? So use this 30 seconds. Okay. Read the question. Jaldi se. Whatever answer you get, just give it to me. And after that, I'll start solving it for you. Done? Okay, now I'll just look into the options here. I'll only read out the names with the correct answer. Okay? Don't think that I am biased or something. So I could see someone giving me the option. Devika, very good. The first person to give me the correct answer. There, Mansi there. Option B. Sudeep B, I guess so. Very good. Sudeep. Then anyone else want to give me the answer? Mansi, oh, Mansi already told, right? Good. Sana, very good. Keep it up. Anshika, amazing. ठीक है. Now, this is a very good question. I got it from NCERT only. Okay, this is a very beautiful question. देख ले, from NCERT exercises you can find the same question. An air bubble of volume, ये क्या हो गया? 1 centimeter cube. ठीक है. rises from the bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. Don't forget to convert into Kelvin. To what volume does it grow when it reaches the surface, which is at a temperature of 35 degrees Celsius? We need a perfect picture here for doing this. देख ले. So this is the surface of water, right? And initially the air bubble was at a depth of 40 meter from the surface, right? Where its initial volume V1 was 1 centimeter cube, right? Fine. And what else is given? Temperature, right? What is the initial temperature? 273 plus 12, 273 plus 2, 275, 285, ठीक है, 285 Kelvin हो जाएगा. अरे very important to convert this into Kelvin scale. V1 है, T1 है, can I get pressure also? Is it possible to get the pressure at this particular point? Because pressure changes. We are going to talk about two different cases. One at the bottom, when the bubble is at the bottom, and when the bubble is on the surface. Obviously, we know that at this point, when it is at the surface, the pressure is atmosphere. When it comes down, it will be increasing by properties of fluids. We have learned pressure is equal to, here if it is P atmosphere, it comes down by H, right? So it is P atmosphere, pressure at the point 1 is atmospheric pressure plus we are coming down by H, so H rho G. Fine. We can substitute the values even. P atmosphere is 1.01 into 10 power 5 plus height is 40, density of water is 10 power 3 and G is 10. So we got V1, T1 and P1. Question to find V2 is the temperature at this point given 35 degrees Celsius. So plus 273, how much? 5 plus 3, 8, 7 plus 3, 10. So 2 plus 1, 3. Temperature is 308. What is the pressure? Now it is in the atmosphere. So on the surface, pressure is equal to, sir, atmospheric pressure कितना है? पता है ना सबको? 1.01 into 10 power 5 Pascal. Which law? Combined law. Combined law says that P1 V1 by T1 क्या है? P1 V1 by T1 is equal to P2 V2 divided by T2 से. ठीक है. Now 1.01 before substitution I'm going to consider it as 1. मतलब 1 into 10 power 5 plus 4 into 10 power 3, 10 power 4, this 0, 10 power 5. So 4 into 10 power 5 plus 1 into 10 power 5. How much is it? 5 into 10 power 5. So pressure 1, 5 into 10 power 5. Initial volume is 1. Initial temperature is 285. ठीक है. Now pressure P2 is 1.01 into 10 power 5. Like I said, we can just simply write it as 10 power 5 for simply simplicity in calculation. ठीक है. And temperature T2 is 308. So fine. So what all will cancel? 10 power 5, 10 power 5 will cancel. What we have in remaining is V2 equal to, देख ले, 308 will come up by 285 we have. Then on the top 5 into 1 is 5. देख ले, 308 by 285 is a value a bit greater than 1. छोटू ऊपर. It will increase the value of by 5 by छोटू ऊपर. So answer becomes छोटू greater than 5. And छोटू is 5.2. आ गया. Have a look at it. Okay, try to solve it, and within 10 seconds we're gonna start a new topic. So everyone go for it. Shreya, yes. Avanshika, yes. Broken Girl, Rizik, Mera, Math Physics, Okay, so after the next concept, Mansi did the entire math in the chat box. You're a very good typer there, typist, let's say. Okay. Physics timetable for what? My classes. For 11th, it happens on Tuesday, Thursdays, and Friday. Tuesday and Thursday at 8 p.m., Friday at 10 p.m. Now, I think I have promised you one song yesterday, okay? As this is the beginning of a new chapter, right? It has to be happy. So, we'll start a song at almost after the Avogadros Law, okay? After Avogadros Law, we are gonna sing a Chotu song. ठीक है, देख ले everyone. New law we have Avogadros Law. Everyone, write the heading. What is said in Avogadros Law? Whichever law it is, we have to keep something constant. So what are going to be constants here? So the constants are pressure and temperature if we keep constant. Okay, the word keep is very much necessary, right? Okay. I thought of making it as a short. Anyway, pressure and temperature if we keep it as a constant, Avogadros law says that same volume of gas has same number of molecules. Very simple. If I take same volume of a gas, it will be having the same number of molecules irrespective of the gas, but make sure that pressure and temperature are kept constant. I'll explain you. Here I have hydrogen. Okay? Here I have oxygen. Both temperature and pressure are kept constant. Both are having the same temperature and pressure. Matlab ye hai ki if I take a 10 liter and if the number of molecules are 100 here, and obviously if I take 10 liter of oxygen, it will also be having the same number of molecules, that is 100, and this is said in Avogadros law. Okay, irrespective of the gas, whichever gas let it be, if we are keeping temperature and pressure constant, same volume will have same number of molecules, or we can say volume directly proportional to number of molecules. Okay. Now, number of molecules increases, number of moles increases. Okay. Moles is equal to total number of molecules by Avogadro number. Okay. So, number of molecule increases, what will also increase? Number of moles also increase. Sabko pata hai, right? So, we can say volume is directly proportional to number of moles, and that is what Avogadros law is. क्या है ये? Avogadros law. क्या है ये? Avogadros law. Very important. Okay, volume directly proportional to number of moles. Just that pressure and temperature has to be kept constant. देख ले, if you need another example, I'm taking 10 liter of oxygen and let's say it has 1 mole. Fine. Now I'm taking hydrogen. Sir, आपको ऑक्सीजन हाइड्रोजन ही पता है, दूसरा गैसों को नहीं पता है. अरे I'm not here to show off, है ना? Show off करना, even if I try to show off with chemistry, I don't know much. Maybe you guys will be knowing much better. ठीक है, 1 mole of oxygen I take and hydrogen also at the same temperature and pressure. Both are having same temperature and pressure. If I take 5 liters, how many moles will be there? Volume proportional to number of moles irrespective of the gas. So if 10 liter can have 1 mole, 5 liter, half the volume can have half the number of moles, so which means half mole. समझ में आ रहा है ना सबको? आ रहा है ना सबको? आ रहा है या नहीं आ रहा है? आ रहा है? ठीक है, अच्छे से नन्हे मुन्ने से. Okay, 0.5. Very good, very good, very good. Now it's time to combine all the laws, है ना? So I think you have seen the Spider-Man movie. So in the latest Spider-Man movie, right? All the Spider-Mans from all the universes getting unified. ऐसे हो रहा है इधर. Now we are going to unify all the laws. ठीक है? We are going to embrace all the laws that we have learned till now. Can we do that? Okay, अच्छा हो जाएगा. ये तो हो गया ना, number of moles, Avogadros Law सब. ठीक है, देख ले. What all we have learned till now? Volume inversely proportional to pressure. Volume directly proportional to temperature. Boyles, Charles and Avogadro. Volume directly proportional to number of moles. If you keep everything and make it as one single equation, it's gonna be volume proportional to temperature and number of moles and inversely proportional to pressure. Now, if you convert this proportionality into an equation, kaise? That constant is R. Proportionality equation, we have to multiply it with a constant, and that constant is R here, NT by P. P, if you take it to the left hand side, we have PV is equal to nRT, which is our ideal gas equation. Which is our ideal gas equation. देख ले, the name itself for the equation has ideal in it. मतलब these laws are applicable to ideal gases only all the time. There are certain conditions under which real gases will be obeying this equation. That condition is one condition we have learned, higher temperature. ठीक है, डन डना डन इधर तक. Have a look at it. हो गई बात. PV is equal to nRT. हो गया, बात हो गया. हर्ष अभी आकर पूछ रहे हैं सर आप क्या कर रहे इधर, है ना? It feels like तू गाली दे रहा है. Okay, it is just like coming into someone's class and like, sir आप क्या कर रहे हैं? Looks like I'm teaching and nobody is understanding. I hope that is not the question which you meant, right? And we are doing a kinetic theory of gases. Jokes apart. Clear, right? Note भी किया है ना? अरे very important है. If you have anything to be noted from the Avogadros law, मतलब the first part here, have a look at it. Once again, I'm showing you the slides so that you all can note it down. Sir, എന്തെങ്കിലും മലയാളത്തിൽ പറയാമോ? So by reading that statement, I think I said something in Malayalam, right? हो गई बात? आ गया तो आ गया, समझ तो आ गया. बिल्कुल, awesome. Platinum clear, noted also. मजा भी आ गया, ठीक है. Now we will proceed further and have a look at this ideal gas equation also. Note भी किया सबने, ठीक है. Now yesterday, we haven't completed the class. Class will be extending till 9:30, half an hour more. So in order to give a chotu break, and as I have already promised in yesterday's class, to all my dear super awesome बच्चा लोग, एक छोटू सा song, ठीक है? What a song, everyone? हो जाएगा, है ना? छोटू सा नन्नू मुन्नू. Okay, here we go. Nannu Munnu song. La 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 la. La 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 la. डूबा डूबा रहता हूँ आँखों में तेरे, दीवाना बन गया हूँ मैं तेरी चाहत में तेरी. डूबा डूबा रहता हूँ आँखों में तेरी, दीवाना बन गया हूँ मैं तेरी चाहत में तेरी. अब दिन गुजरती नहीं, रात कटती नहीं, तस्वीर से बात बनती नहीं, तू आजा, कोई जाने ना पहचाने ना ये हुआ कैसे, तुम आओगे ख्वाबों में ऐसे, कोई जाने ना पहचाने ना ये हुआ कैसे, तुम आओगे ख्वाबों में ऐसे, बेवफा 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 न जा, रूबरू रहता हूँ आंखों में तेरी, दीवाना बन गया हूँ मैं तेरी चाहतों में तेरी, रूबरू रहता हूँ आंखों में तेरी, दीवाना बन गया हूँ मैं तेरी चाहतों में तेरी. Okay, so there you go, मेरे बच्चा लोग. So I kept my promise, and here we are. I hope you all like it, right? You're great, sir. Sir, wow, आ गई सपना. Okay, thank you so much, Shreya. Nice voice. Okay, yes. You are pro Ameer, sir. Fully. Amazing teacher plus awesome singer is equal to students interested. वाह वाह वाह, students started making equation out of me. ठीक है, ठीक है, ठीक है. Anyway, thank you so much everyone. बहुत 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 धन्यवाद. I'm so happy to get all the compliments. So अब बाकी क्या है? अरे बहुत सारे हैं पढ़ने को. अरे पढ़ने वालों वापस आ जा, है ना? अरे वापस आ जा. We know just now we have made the equation of PV is equal to nRT. Why no one is asking, sir, ये constant को कोई नाम है क्या? We keep on adding so many constant and we don't give any values, है ना? Values भी नहीं दे रहा है constants को. So constant itself will get angry, right? So इसी constant को एक नाम भी दे दिया, पहचान भी दे दिया, एक number भी दे दिया. What is the name given? What is the name of our universal? ठीक है, gas constant. It is called as universal gas constant. Does it have a value? Yes, obviously. The value of R is 8.314 joule per mole Kelvin. So once we express R in its SI unit of energy, which is joule and mole and Kelvin, the value of R is found to be 8.314. And why the name universal? If we find the value of R here in Earth, if we find the value of R in moon, wherever you go, universe पे किधर भी जा, ठीक है, take a rocket, keep on flying here and there, try finding out the value of R, है ना, by doing the experiment, you'll get it 8.314. you'll be like, sir, हम पागल है क्या ऐसे R का value ढूंढने पे? So got this, I suppose. ठीक है, देख ले. Now we are entering into another part. Okay, for this particular thing we made all the derivations till now and we have learned all the things, right? The second condition at which a real gas will be acting as ideal. For this thing we were making all the studies till now. देख ले. Once again let me write. The formula is PV is equal to nRT, or PV by RT will be equal to N. N corresponds to number of moles. देख ले. For 1 mole of any gas, for 1 mole of any gas you take at any pressure, at any temperature, मतलब I am changing the value of pressure, volume, temperature, whichever value I change, it doesn't matter. For 1 mole of any gas, what will be the value of PV by RT? What will be the value of PV by RT for an ideal gas? क्या हो जाएगा आइडियल गैस के लिए? PV by RT value. PV by RT value for an ideal gas at any condition or situation, at any pressure, at any volume, at any temperature, any gas, it will be equal to 1. Shall we plot the same in a graph here? Let's plot the same in a graph. देख ले, on the y-axis I'm going to plot PV divided by RT, and on the x-axis I'm going to plot pressure. whatever may be the value of pressure, let it be here, 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 whichever may be and whatever may be the pressure, what will be the value of PV by RT? PV by RT will always be having a value of 1. मतलब the graph will be ऐसे. देख ले, at whatever pressure, PV by RT will be equal to 1. And this is for ideal gas. ठीक है, ये तो ideal gas के लिए. Sir, real gas के लिए भी है ना? Give some consideration for real gases also. Draw the graph for real gases also. मतलब I took a real gas in a container, right? I kept on changing the pressure. I found out the value of PV by RT at each pressure. And how the graph was looking like? For a temperature of T1, the graph was looking like this. ठीक है? And at a temperature of T2, the graph was looking like this. Okay? For real gas at two different temperatures. Now if you look here, right, T1 is making a low deviation where T2 is making a large deviation from the ideal gas behavior, which is a straight line. So at which temperature we can expect Chotu deviation? For what temperature of real gas we can expect a small deviation from ideal gas? At higher temperature, है ना? So the graph at a temperature of T1 देख ले makes less deviation compared to the other graph. So which temperature will be higher? T1 will be greater than T2. No doubt in that. Because at higher temperature, deviation will be less. That is not my point here. Our point is, देख ले, when the graph was started at all the other pressure values, देख ले, at all the other pressure values, right, there is a deviation between real gases and ideal gases. But if you look at the initial part, all the value of graph, है ना, all the values in the graph are very close to each other. मतलब you can see that at small value of pressure, the graphs are coinciding each other, or we can say that it is at lower pressure. What is it? It is at lower pressure the real gases will be behaving what? Behaving ideal in nature. समझ में आ गया? So from this graph, this is the information you have to grab. What is the information मेरा बच्चा लोग? Information ये है कि it is at low pressure. How I concluded this once again? देख ले. At low pressure, we can see that all the graphs are very close to each other, or we can say coinciding each other, right? So that's the reason why we say at chota value of pressure, at low pressure, a real gas, okay, will behave like what? An ideal gas. So we got the final two conditions for an ideal gas to be almost close as for a real gas to be almost close as an ideal gas, or for a real gas to obey all the gas laws. Which are the two conditions? One is at high temperature, okay, and the other one is at low value of pressure. Note this down, and for understanding this thing, we have made so many laws and we have done the studies till now. Very important है मेरा चलो. Important मतलब उत्ता ज़्यादा important. उत्ता मतलब उत्ते से उत्था. Sir, is any real gas? It is not like okay, ideal gases are existing. Okay, वो तो imaginary situation है, ठीक है? So, in that imaginary situation of ideal gas, whatever gas exists, उसका नाम है real gases. Whichever gas we have, है ना, in this universe, we call it as real gases. Sometimes this real gases will be showing its ideal behavior. We have started this chapter by giving me an example, है ना? Okay, every parents will be having an imagination on how their kid should be, right? That imagination wala kid ko we call it as ideal kid, right? And the kid will be all obviously so much different from those imagination. We call the actual kid as real kid. Sometimes this real kid will be matching up with the imagination of the parents. Okay, so similarly here sometimes हमारा real gas will be matching up with the ideal gases, and that matching up happens at low pressure and at high temperature. ज्यादा समझ में आ रहा है ना सबको? What is difference between अभी मैं समझाया, समझ में आ गया? देकर बोल, मुझे आंखें में देकर बोल. Right now I'm looking at the camera. At least I'm not an ideal kid. Wow, what an honest kid here, है ना? यार at least that honesty part is there in you, है ना? You are saying that kids like me? Yes, of course, है ना? ठीक है? समझ आ गया? Compressibility factor इसी चैप्टर पे क्या क्या क्वेश्चन पूछ रहा है? I am talking about A. You guys are asking what is 1. अरे when we learn about alphabets, not about numerical system. ठीक है? Compressibility factor not now. When I keep some general doubt clearing classes, you can come and ask me. ठीक है? अभी तो नहीं. Clear है ना? ठीक है. Go for the question मेरा बच्चा लोग. अगला क्वेश्चन आ गया. क्वेश्चन करने का वक्त आ गया. ठीक है? तो वक्त भी आ गया, सब भी आ गया. करेंगे हम. सर करेंगे हम. Okay, ये तो सिंपल क्वेश्चन है. मतलब by using the Avogadros law, we can do this problem. Everyone, jaldi kar le. We have an important, bit lengthy question that is coming on our way. So everyone, be prepared. Everyone. हो गया बात? Is it clear? मतलब done. Who's going to give me the answer, B? Anyone? Who's going to give me the answer? साक्षी पटेल बोल रहा है कि सर वो तो A है. ठीक है. मिथिलेश बोल रहा है A. सपना A. ऋतु ठाकुर. ठीक है. Everyone is giving, right? सुदीप A. Okay, बढ़िया. Broken. ऋतु ठाकुर सना. I think A maybe. ठीक है. Broken. Okay, everybody is going for the option. ये तो simple है, right? देख ले. 1 mole of helium gas. Initial number of moles is 1 mole. Okay. Fills up an empty balloon to a volume of 1.5 liters. What would be the volume of the balloon if an additional of 2.5? So is the N2 value 2.5? बिल्कुल नहीं. Additional 2.5 is added. मतलब already 1 mole था. Okay, to that 2.5 is added. I don't know how to show 2.5 within my hand. ठीक है. So 2.5 plus 1 कितना? 3.5. So N2 is not 2.5, 3.5. Okay, उतना मोल ऐड किया है. ठीक है. And question क्या है? What would be the volume? V2. So how to do this? अरे volume directly proportional to number of moles, right? So V1 by N1 equal to V2 by N2. V1 1.5, N1 1, V2 पता नहीं, N2 3.5. ठीक है. So V2 equal to 3.5 into 1.5, 5.25 liters. Answer A. I'm not asking whether have you understood or you have any confusion. नन्नू मुन्नू question है. ठीक है. अगला जा रहा हूँ. Going for the next one. Here we go. Okay. Give me the answer within 10 seconds. Give me the answer within 10 seconds. Jaldi. Everyone. Just 10 seconds. That is more than enough. वो भी काफी है. So which chapter is this? क्यों रो रहा है लोटस आप? Whichever chapter it is, why you have to cry there? It's a kinetic theory. Clear, Shreya, Sumit. अरे instead of asking है ना which chapter it is, अरे आंखें खुलकर देख, टाइटल पे लिखा है सब. So many are asking, so which chapter आप कर रहे हैं, which chapter कर रहे हैं? अरे YouTube पे टाइटल देख ले आप लोग. It is written kinetic theory. So now, Miara, anyone who wanna give me the answer? Who wanna give me the answer? अरे इतना simple question, nobody can answer. Mithilesh, yes, option B. Raghavi, option B. Sumit, option B. Anshul, option B. Okay, yes, yes, yes. It's option Raghavi Ritu. अरे कुछ भी नहीं करना है. It's option B. Very good. A tire containing 10 moles of air. Initial volume is 10. Sorry, initial number of moles is 10, and initial volume is 40. Loses half of its volume due to a puncture. Considering that the pressure and temperature remain constant, Avogadros Law, what would be the amount of air in the deflated? Matlab, if half the volume goes, right, how much moles remain? Matlab, if half volume goes, the amount of air remaining is half only. Half तो गया, half तो बाकी है. ठीक है? So if volume is half, volume proportional to number of moles. If volume becomes half, number of moles becomes half. I'm not doing it V1 by N1, V2 by N2, है ना? हो गई बात. So volume half, number of moles half. Initially it was 10, half हो जाएगा तो 5 moles, है ना? नन्नू मुन्नू, कैसे क्वेश्चन? नन्नू मुन्नू, नन्नू मुन्नू. हो गई बात? Okay, now shall we do a very good question? Sir, what do you think about school law? Wow, what a beautiful question. ठीक है, now let me ask you a question, Amish. What do you think about asking this question to a teacher? आप उसके उत्तर पहले बोल दे, ठीक है? फिर मैं बोलूंगा, okay, how does it feel? अरे ये सब infatuation है. Don't spend time on all those things. You'll get enough time during your college times and all. ठीक है? अभी पढ़ने का टाइम है बच्चा लोग. ठीक है? कुछ पढ़ ले. Get some good rank, get into good colleges, okay, and get some good career. ठीक है? पैसे होना चाहिए. ठीक है? नहीं तो सब छोड़कर जाएगा. ठीक है? मैं बोल रहा हूँ, याद पे रख ले, पैसा होना चाहिए. Whatever what's say motivational talks we have, right? Whatever other different worlds we talk about, है ना? ऐसे जिंदगी ऐसा होना चाहिए. It should be so peaceful. It should be happy. But everything at last, in some point of it will come to money. ठीक है? होना चाहिए, नहीं तो सब छोड़कर जाएगा. ठीक है? So अभी वक्त है कि पढ़ने का. ठीक है? कर ले. नहीं तो अभी तो सब हो जाएगा. ठीक है? स्कूल के बाद कुछ भी नहीं मिलेगा. ठीक है? तो हो गया ना बात? नन्नू मुन्नू क्वेश्चन. सो आई आंसर्ड माय क्वेश्चन, आई सपोज. ठीक है? अगला कर ले. ये तो थोड़ा करना है बच्चा लोग. लेट दिस बी द लास्ट क्वेश्चन ऑफ टुडेज क्लास. फाइन? एंड एवरीबॉडी कैन ट्राई डूइंग दिस एंड यू कैन गो फॉर द आंसर. Just try to read the question and understand. It's a big question. I'm not asking you to do it within some time period. And it's not so possible to do it within some time period I have here. ठीक है? Completed reading everyone? ठीक है? I'll do this for you. ठीक है? थोड़ा बड़ा question है. तो मैं करेगा. देखिए. An oxygen cylinder of volume 30 liters, we have a cylinder, ठीक है? And its volume is 30 liters, has an initial gauge pressure of 15 atmosphere, right? and a temperature of 27 degrees Celsius. Volume is 30. ठीक है. Pressure is 15 atmosphere. 1 atmosphere is 1.01 into 10 power 5. So 15 atmosphere is 15 into 1.01 into 10 power 5 Pascal, which is the SI unit of pressure. And a temperature of 27 degrees Celsius. So initial temperature is 27. Array, don't forget to add with 273. क्यों? क्योंकि आंसर मिलना है ना सही. So सही आंसर मिलने के लिए डिग्री सेल्सियस conversion to Kelvin is very important. 27 plus 273, that is 300 Kelvin initial temperature. Okay, this is the initial case. After some oxygen is being withdrawn from the cylinder, the gauge pressure drops to 11 atmosphere. Let's say initially the mass of gas present was m1. ठीक है. Now we have the second case. Second case पे क्या हो रहा है? From the same cylinder which has the volume of 30 liter, we are taking out some oxygen. इससे some oxygen is being taken out. मतलब क्या होता है? If oxygen is being taken out, mass will reduce. Now the current mass is m2. Fine. And the pressure at this point is, pressure is how much? 11 atmosphere. That is 11 into 1.01 into 10 power 5 Pascal. ठीक है. And its temperature drops to 17 degrees Celsius. Can I use it as 17 itself? No. The final temperature is 273 plus 17, that is 290 Kelvin. Estimate the mass of the oxygen taken out of the cylinder. If we get initial mass and if we get final mass, subtracting the final mass from initial, won't we get the amount of mass that has lost? Let's say initially 30 grams are there. After the gas oozes out, after some time it is only 20 grams are there. Okay? So can't you find 30 minus 20, the amount of gas that is gone out or escaped? How much? 10 grams. So we need to find this m1 and m2. So that is our duty. ठीक है? करेगा कैसे? अरे we all know the ideal gas equation. P1 V1 is equal to N1 R T1 sir. So what is P1? That is 15 into 1.01 into 10 power 5. ठीक है. Volume कितना? 30 liters. Don't forget to convert into meter cube by multiplying it with 10 power minus 3. N1, number of moles in the first case. Formula क्या है? Given mass, that is M1, divided by molar mass of oxygen, 32 grams. So 32 into 10 power minus 3. Calculation तो ज़्यादा है. I can understand. R is 8.314 and temperature is 300. देख ले. What is the only thing that is left? Unknown M1, right? So if you solve it, okay, आप लोगों को मिल जाएगा mass in grams as 584. ठीक है. बचा लो. You guys are best है ना? You guys are faster than me in calculations, I suppose. So that is the reason why I'm leaving all these calculations to you. ठीक है? आप करेगा ना? Similarly, can't you find M2 also? Similar. That is P2 V2 equal to N2 RT2. If you want me to write, we can write. देख ले. P2 V2 equal to N2 RT2. P2 is 11 into 1.05 into 10 power 5. V2 volume is 30 liter itself. 30 into 10 power minus 3. N2 is given mass by gram molecular mass. Same thing I'm writing. 8.314 into temperature is 290 Kelvin. देख ले. I think you all can see that. Right? What is only unknown? M2 है. So M2 you will be getting around 453 grams. Question is कितना बाहर गया? How much we had initially? How much we have right now? What we have to do? What we had minus what we have right now, subtract कर ले. We'll get the amount that is being lost. So 584 minus 453. M lost is equal to M1 minus M2. ठीक है? So that is 584 minus 453. That will come around 132, I suppose, right? Almost 131, 132 आ जाएगा. कितना आ रहा है? 131 आ रहा है ना? 84, 453 will be, this will be 131, है ना? This will be 131 because 4 minus 3 is 1. 131 आ जाएगा. But 31 answer is not here, so we can approximate to 132. Other values are so much away from this 131 value. So approximate करके we can go for the option A there. आ गया समझ मेरा बच्चा लोग सबको? Is it clear? Is it clear मेरा बच्चा लोग? Just tell me. Yes. Okay, you all gave the answers. Very good, right? I don't think it's a tough problem. What do you call this problem as? Right? बड़ा problem है ना? ये तो बड़ा problem है. जिंदगी में छोटा problem होता है, बड़ा problem होता है, confused problem होता है. This is a बड़ा problem of our life. इस full chapter one shot. अरे मैं तो मर जाऊंगा ऐसे. Right, we will be having the next class. Array, this was the last topic. I thought of taking kinetic theory of gases also in today's class, but that was not possible from my side. Okay, it is already 1.5 hours. So, sir, broken girl is kuch telling something. Okay, ठीक है, let her tell है ना. Bye, मैं अपने माँ बाप की Okay, fine. Is it clear? Fine. Okay, so कोई भी नहीं है ना, कुछ भी नहीं है. I suppose nothing is left. भैया मेरा डाउट देखो भैया. Okay, so when I see something chat which is not so good and something which I cannot talk publicly, do you know what I do? Yeah. Right? ठीक है. So हो गई ना बात? समझ में आ गया सबको? So ठीक है, सब समझ में आ गया. अरे किसको इंतजार कर रहे हैं? अरे मूव द कर्सर मेरा बच्चा लोग. Just click on that like button, है ना? ज़्यादा like हो गया तो after I stop streaming है ना, once I see that those much of like, I'll feel that so happy है ना, because I'll feel that हाँ मेरा बच्चा लोग मुझे इतना प्यार कर रहा है. देख ले, you are making me happy and making other person happy is the best thing you all can do in life है ना. You will be like, sir, like मिलने के लिए कुछ ना कुछ तत्व बोल रहा है ना. बच्चे लोग, after half an hour I'll use this half an hour for eating. Okay, half an hour के बाद हमारा एक class है on thermal properties of matter in our platform. Okay, it's completely free है मेरा बच्चा लोग. this special class है ना, ये तो free है. So ये हमारा special class है मेरा, चलो ये तो free है. Okay, today at 10 PM देख ले, 27 Jan आज ही है ना. हाँ, 10 PM आधे घंटे के बाद है ना. हाँ, तो कर ले, आ जाओ. Everyone join me for this class of thermal properties of matter. We are going to discuss some important question. Those who haven't joined the classes before and those who haven't downloaded Unacademy learning app, this is your chance. Download Unacademy learning app, free है. ठीक है, login कर ले, वो भी free है. ठीक है, और क्या free है सर? उससे login करके मेनू पे जाना भी free है सर. ठीक है, और क्या free है? और चलो फिर स्पेशल क्लिक करना, वो भी फ्री है. एंड फ्री में आपको कोड भी मिल जाएगा मेरा. वो कोड क्या है? AMB10. यूज कर ले हमारा कोड ऑफ AMB10. ठीक है, एंड एंजॉय कर ले आपका जिंदगी. यू कैन बी अ पार्ट ऑफ दिस पर्टिकुलर क्लास. 10 PM. नाउ रिपब्लिक डे स्पेशल ऑफर इज गोइंग ऑन. दिस इज द लास्ट डे मेरा बच्चा लोग. यू विल गेट एक्स्ट्रा 6 months ऑफ फ्री इफ यू गो फॉर 12 months ऑफ सब्सक्रिप्शन और मोर देन. ठीक है, एंड फॉर 10% ऑफ एक्स्ट्रा कोड तो पता है आप लोगों को, AMB10. Fine. Now an Academy Prodigy program is going on मेरा बच्चा लोग. If you want to get a 20 lakh scholarship For your colleges, this is your time. You can come and write. This is also free. You just need to type in the code of AMB10, okay, the referral code while you register for this Unacademy PG program. For each classes, their respective dates for writing the test is also given here. Fine. Now, as you can see, other than the scholarship for the rank 1, Apple का laptop मिल जाएगा, rank 2 and 3 Apple iPhone, wow, awesome, right? 4 and 5 iPad, Amazon Echo Dot, Amazon vouchers, सब मिल जाएगा, सब, ठीक है? Now, Shukriya मेरे बच्चा लोग, thank you so much. I think it's time for me to leave and I'll be appearing at 10 p.m. in the app with a special class. Don't miss it. Fine. So thank you so much once again. Those who haven't liked the session, those who haven't shown some love towards your bhaiya, this is your time, and subscribe to the channel. I'll be sharing the notes of this particular class in the Unacademy class 11th and 12th Telegram channel. Link you can see it on the bottom. Okay? So you can download the PDF from there. So bachalo, thank you everyone. Bye bye. Good night.